Apparently, you don't need to spend a weekend at Bernie's in order to see a corpse bust a move. Whether it's rigor mortis or gas buildup, this is what it means when you see a dead body wriggle and writhe. Sure, dead bodies moving around on their own sounds fake, but there's actually some historical precedent for it. Maybe it's one you've heard of. The time was the French Revolution, and the method of execution was the infamous guillotine. Those who had their heads lopped off were supposed to die instantly. That's what would make the most sense. But then the decapitated head suddenly moves. According to Thought Co., after Charlotte Corday was executed for the assassination of French revolutionary Jean-Paul Marat, her severed head reportedly gave a disgusted look after being slapped in the face. While the stories are probably exaggerated, possibly for use as propaganda, there might be a bit of medical truth here too. If the blade was sharp and the cut was clean, the head wouldn't sustain much trauma, aside from losing a body, but this is all relative. In that case, there's no reason why the brain wouldn't technically still function until blood loss finally led to death. So that decapitated head with the moving eyes? They might have still been alive.
Ain't got no body, and nobody cares for me. Igor!
But because consciousness is another question entirely, it's impossible to say for sure if the heads were aware of what they were doing. That said, there's actually some research on heads briefly living without bodies, but it's not like scientists are just able to go chopping off human heads to see what happens. The research was actually done on rats. Newsmedical.net summed up a study on the brain waves of rats pre- and post-decapitation. The rat's brain activity before decapitation gave a baseline, normal thought and perception. When the head was cut off, those electrical signals didn't stop for about 15 seconds. Whether the rat was exactly conscious is debatable, but that decapitated head was still capable of things like sensory perception. The brain was still technically alive and firing electrical signals through the perfectly viable neurons. And weirder still, the researchers received one last spike of brain activity around a minute after all those electrical signals had seemingly stopped. Yeah, those neurons are still working, even when you'd think they should be dead. What technically counts as death? Is it when there's no heartbeat or when brain activity completely ceases? Because those are technically two different things, the paper Electroencephalographic Recordings During Withdrawal of Life-Sustaining Therapy Until 30 Minutes After Declaration of Death in the Canadian Journal of Neurological Sciences explains that this is actually kind of concerning. The minutes surrounding death aren't well understood, so could a dead body still be conscious during organ donation?
Those are our organs! Get back on that slab!
If decapitated rat heads show brain activity post-decapitation, it's a valid question. So the team behind this paper measured brain activity and heart rate on 4 patients as they were taken off of life support. Long story short, the patient's brain activity generally stopped before their hearts. But then the story gets weird. 3 patients' brain activity decayed, but the 4th's didn't. Instead, for 10 minutes after being declared dead, there were still recorded spikes in brain activity. Newsmedical.net explains that the brain activity looks similar to deep sleep. The team considered some external variable but couldn't find any, ultimately settling on no explanation. It's just a case study within a case study. No, the bodies didn't move, but the point is, death is strange, so a moving corpse? Maybe not as far-fetched as it seems. So to get into why a dead body might move around, it's kind of helpful to understand what physically happens to us after death. According to Florida State University, rigor mortis is one of those things, essentially a body stiffening up after death. Over the course of a couple of days, post-mortem, a body will go from limp to stiff to limp again, mostly resulting from chemical reactions in the body. Acids build up in the muscles, make them stiff, and then, over time, that stiffness just goes away. But that's not all. Rigor mortis involves how the body cools down. Livor mortis refers to the way blood ends up pooling in the body due to gravity and the lack of a beating heart to pump it around. All of those things happen within the first 48 hours or so, with decomposition setting in later. But rigor mortis could play a part in a dead body moving. Death is a pretty dynamic process. The term cadaveric spasm really sounds like the perfect answer here, maybe too perfect because it's a complicated term. Technically, the term refers to almost instantaneous rigor. A paper by Paul J. Bedford and Michael Sukos explains that instead of stiffening about 20 minutes after death, certain muscles sometimes stiffen immediately. That said, the term is usually used incorrectly. James R. Gill claimed in a paper that even medical dictionaries have defined it as an irregular onset of rigor mortis. The phenomena come with stories, of course. A 1999 paper called Post-mortem Movements tells a doctor's story as he witnessed the toe on a dead body moving up and down. The presumed explanation at the end is that rigor had set in irregularly, and the muscles were stiffening unevenly, causing movement. A colleague of the author seemed to agree, too.
What did you expect? You're dead.
An article by The Sun mentioned something similar, the twitching finger of a dead girl. Cadaveric spasm is used to explain that this might be a case of sudden rigor making the muscle spasm. This is a slightly different definition of the term, but it's somewhat closer to the idea that muscles might still respond to external stimuli, causing twitching. So the exact meaning of this term seems debatable, though most of those meanings are still relevant. Getting into some very new and strange territory, studies on bodies moving over the course of a whole year are basically non-existent, but there is one strange case study. Allison Wilson, the principal researcher for this study, started out by using time-lapse photography to map the decomposition of bodies in the Australian environment, but then ended up using that process to start mapping post-mortem movement. By taking pictures of a body over the course of 17 months, the team discovered that the body moved a lot. It doesn't remain still like most people tend to believe. The arms especially are mentioned a lot. Both of them started off at the sides of the body, but they didn't stay that way. At one point, both of them were flung off to one side. By the end, one arm reached out to the side and the other was bent at the elbow, the hand almost touching the hip. All the limbs moved considerably over the 17 months, as did the head and neck. So why would a body move 17 months after death? There isn't an exact explanation for it, and it's most likely a combination of different factors. Allison Wilson mentioned that insects might be part of the reason for the movement. Around 13 days in, there were a lot of insects flying around in the cage, which is a totally normal process. Insects like flies and beetles seek out dead bodies to lay their eggs, which can shift some things around. Wilson figures that all of those insects probably did play some small part in the overall movement of the body at first, and bacteria accounted for a bit more. As a body decomposes, enzymes and bacteria will start breaking down soft tissues inside the body, which ends up releasing gases. The result of that is bloating, because those gases just fill up the inside of this dead body.
Oh, dear God, that is putrid. On a separate topic, do you like coffee cake?
Since Wilson discovered a lot of movement in the arms early on in the decomposition process, that would line up with when bloating happens. So there might have been some gas buildup in the stomach in particular that could have caused the arms to shift around. While we know that rigor mortis stiffens the muscles due to acid buildup, another reason a dead body might move may be due to muscle breakdown. Muscles are basically just big groups of proteins. When muscles are left out to decompose, those proteins break down into smaller compounds. So as the proteins are breaking down, the muscles fall apart. In Wilson's study, the head of the dead body began tilting to the left side after 2 weeks. Wilson guessed that it was potentially due to the muscles in the neck going through that degradation process, making it flex to one side. Of course, neither muscles nor bones would be able to do anything without some literal connective tissue, tendons and ligaments. When ligaments dry up, they contract. That process contracts the joints, too. This would explain why the arms seem to very slowly flail around. One weird detail Wilson's study mentions is that the movement they observed wasn't uniform for the entire body. Both arms moved considerably, while the legs just bent at the knee. And even then, the right arm generally traveled more distance than the left arm. Wilson proposed that the difference in the arms could have been because of handedness, what we call our preferred or dominant hand. Greater movement leads to stronger muscles with a higher moisture content. Assuming that the post-mortem movement is generally due to moisture loss in the muscles and ligaments, then losing more moisture might have led to more dramatic movements. There's a similar argument for the legs. Legs generally have more muscle mass than the arms, so especially in the earlier stages of decomposition, the arms are losing moisture more quickly. A dramatic loss of moisture might also lead to more dramatic movement. Comparatively, even if the legs are losing the same amount of moisture, there's more muscle that needs to move.
Uh-oh, better get moving.
Creepy? Sure, but it's all just a natural process. So if you happen to be out hiking and see a dead body rustling in the leaves, don't go straight for the zombie killing gear. Call the police.